very much, Alan, for inviting me and for organizing the conference. Given the topic of this conference, I'm going to present a sampling of CCA architecture that shows an overview of work in the realm of digital design technologies and related practices that cuts across our research and design labs and their workshops, our lectures, exhibitions, and installations, our digital media coursework that's embedded within our professional and post-professional curricula, and also related CCA faculty, research, and design. In many ways, this reflects my own attitude about both the curation of research and innovation within the realm of academia, especially within the context of professional schools of architecture, and the multiple intersecting networks through which it might be developed. Architecture within the academic environment has always embodied a double-sided agenda, defined on the one side by the need to produce a generation of practitioners who will become professionally competent as architects, and on the other side, the objectives of the academy, whose role it is to produce new forms of knowledge, and through this process to advance the architectural discipline through performative trajectory supporting advanced research. Historically, the separation of the academy from industry was to ensure that the forms of research being developed were intellectually protected and not being controlled or compromised by the demands of the commercial market or predefined, let's say, by pre-existing professional norms, but instead were at the service of other aspirations. Upon my arrival as the Director of Architecture at CCA in 2008, I initiated 3 R&D labs focused on urbanism, ecology, and advanced digital and interactive technologies. These labs were each intended to offer specialized areas of investigation within CCA, architecture that would promote research and design within the academy beyond that which constitutes the foundation of a professional education, while also contributing to faculty and student research in parallel with advanced elective coursework that could support also the development of specialized post-professional degree programs that we're embarking on now. The intention of the labs was to form a critical interface also with an external public and professional network of constituents within architecture, urbanism, and its related industries, to apply the depth and breadth of intellectual resources and capital that exists within the academy to also real cultural, environmental, urban, technological, and material problems. And one of the drivers for this was my belief that the design laboratory could become a vehicle for research that was integrated with coursework and become a strategy to develop project-based collaborations with profession and industry to counter what is sometimes the solipsism that can become pervasive within academia. It was also a way to collectively focus on or curate cohesive topics of exploration that were not necessarily defined as degree programs, yet could link up with curricular streams within these. The Media Lab at CCA supports students, faculty, and local professionals in the use, experimentation, and development of advanced digital design technologies and strategies in architectural production. One of the largest transformations in future architectural practice will be in the realms of rapid prototyping, digital fabrication, robotics, parametrics, computation and scripting, building information modeling, as well as the many models for visualizing information in many fields, including energy analysis, geographic information systems, among many others. The goal of MLab is to foster discussion primarily on these digitally based technologies and to advance innovation within the field while simultaneously providing educational resources and information not only to the CCA community, but also to the architecture and design communities in the San Francisco Bay Area and beyond. And through these labs, we run collaborative workshops that are structured around emerging research topics that are open to students, faculty, and also outside professionals. Their intention is not only to augment the curriculum of the school through intensive sessions, they're generally 1 to 2 day sessions that aren't possible within the existing academic structure, but also given the rapid pace of technological change to provide an ongoing educational vehicle for faculty development as well as the ongoing education of outside professionals. These workshops are taught by CCA architecture faculty, by alums, and also a larger network of Bay Area professionals working within related industries. They also enable us to engage industry partners and media industry partners such as Autodesk in the instruction, sponsorship, and technology support for the workshops, and to potentially more directly influence developments in the industry. We also have developed longer-term workshops such as the Biodynamic Structures 10-day workshop in collaboration with the Emergent Technologies and Design Group here at the AA as part of the AA Visiting School program. This workshop, and this is our what we call our central namespace within CCA, the San Francisco campus. This workshop involved 60 architects and designers from 20 different countries around the world. We've run it for the last 2 summers, and it's focused on interactive and responsive systems. Participants in the workshop investigated biomimetic principles, extracting organizational, geometric, and structural logics to analyze, design, and fabricate prototypes responsive to electronic and environmental stimuli. Advanced analysis, simulation, modeling, and fabrication tools were used to apply this information to the design of responsive architectural systems, and robotic sensors and actuators were used to activate the design of these material systems through working prototypes. In the last 2 decades of architectural practice, new digital technologies have evolved from being representational tools invested in the depiction of existing models of architectural space to becoming performative machines that have radically transformed the ways in which we both conceive and configure space and material. These tools for design, simulation, and fabrication have enabled the emergence of new digital diagrams and parametric landscapes, often emulating genetic and iterative dynamic evolutionary processes that not only change the ways in which we integrate disparate types of information into the design process, but also significantly alter the methodological strategies that we're using for design, fabrication, and construction. After the early digital explosion of the 1990s, new forms of rigor and production, I would say, have now entered into the field of architecture, supported by the emergence of parametric and building information modeling, the enhanced use of computation and scripting that together represent the second critical wave of digital design practices. That our current models of space are far more continuous, variant, and complex, cellular, woven, iterative, modulated, is specifically a result of the tools that we're using to produce them, an inevitable byproduct of the ever-expanding capacities of digital computation and related fabrication technologies as these intersect with theoretical trajectories that long ago dismantled the social, functional, and technological truths of the early part of the 20th century. I would say that typological stasis and structural closure are now supplanted by a topological model that permits infinite mutability and differentiation. Flux, Architecture and a Parametric Landscape, was an exhibition that we did a couple of years ago that focused on this emerging field of advanced digital design. It was generated in conjunction with the CCA Architecture Lecture Series, a series of digital workshops that we ran, a number of CCA courses that were linked up with it, and at the same time, the 2009 International Smart Geometry Conference that was held in San Francisco. The content of the exhibition is organized through a series of thematic taxonomies, each of which explored a set of spatial logics that have been transformed through advanced digital practice. We looked at stacked aggregates, modular assemblages, pixelated fields, cellular clusters, seriality in its iterations, woven meshes, material systems, and emergent environments. In the exhibit, these themes were elaborated through the presentation of 50 built works and experimental architectural projects, bringing together the academic and professional environments, exposing an important trajectory occurring across the academy, the profession, and industry simultaneously. These were then expanded by a series of analytical diagrams and 3D printed models that were generated by CCA architecture students. The Flux installation itself was developed by a team of CCA faculty and students also explores the possibilities of parametric modeling and digital fabrication through the production of the exhibition armature, which was then overlaid with a didactic surface that supported the content of the exhibition. The armature was designed using parametric modeling in a series of custom design scripts. From the thickness of the ribs to the overall twisting geometry and perforated skins, the spatial form of the armature was controlled through a complex set of relationships defined by its formal, performative, and fabrication constraints. A second project that's a permanent installation in our San Francisco campus over a lounge in an existing two-story atrium was called the aortic arc. This canopy was a light scope and spatial definer that was topped by 3 portals that pull light in from above during the day and become a modulated surface when artificially lit at night. The canopy had to be self-supporting and easy to construct and dismantle. It was a lightweight panelized system made from flexible plastic panels that were riveted together. And this was developed by a group of CCA faculty and students working with engineering consultants from Bureau Happold. The team developed the project using generative components in combination with CNC milled full-scale mock-ups to verify the fabrication technique. And here, in terms of an organizational process, that we were linking up a kind of working team in many of these projects of students, faculty, including alums and also professional expertise from the outside, as well as getting industry support in terms of both knowledge and material, was an important juncture for us in moving some of these projects forward. Flexible computer-controlled automation and the potential for mass-customized architectural components will certainly transform building practice. Although these have been emerging within academia, where research continues to grow, the continued development of this almost demands an integration of the academy, industry, and the profession to support these larger endeavors. In this, we should also be looking to other disciplines who have for many years integrated research, industry, and professional education, I would say, in advance of architecture. The studio project that was focused on the renovation and transformation of the Asian Art Museum in San Francisco, for example, was partnered with Chrysler and Associates, a firm and industry company that deals with composites, fiberglass, and Front Inc., which is a facade engineering consultants, to specifically develop strategies for prototyping composite building skins by generating facade panels using parametric modeling and digital fabrication technologies. In this process, students worked in Chrysler's facilities, fabricating full-scale fiberglass and composite prototypes to test the process of fabrication. The industry itself helped us by educating the students in the material processes and worked with us collaboratively throughout the entire process. In design build prototyping projects such as Rapid Type, which was a mobile prefabricated coffee pod, the link with industry was also critical. This was a CCA Advanced Studio project that was made possible by a material donation of Alpolic, a unique aluminum composite material manufactured by Mitsubishi Plastics. The intention of the project was to develop a design strategy that would investigate the potential use of the composite material. So in this case, we were actually approached by industry to explore potentials for the material product itself. Employing CNC fabrication technology while aiming to bring higher end design to the prefabricated mobile food cart, which is a programmatic type that has been expanding rapidly in the San Francisco Bay Area. Taco trucks seem to abound, so we thought we would design our own potential mobile cart. Within the context of our digital technologies and related curricula, there's 4 primary areas that we are focusing on: parametric design and scripting, digital fabrication, advanced visualization, and robotics and interactive technologies. Parametric design and scripting involve courses such as generative design that explore computational strategies for both architectural analysis and design, that reconceive form-generating strategies. New computational tools and programmatic code emulate iterative, dynamic, evolutionary processes where architecture now emerges almost as a genetically driven organism, enabling new spatial typologies dependent on the simulation of generative patterns of form growth and development. Digital fabrication, which involves courses such as synthetic tectonics and studios such as RapidType, are specifically focused on the use of rapid prototyping technologies such as laser cutting, CNC milling, and 3D printing. Innovations in this area, such as linking programming to robotic production, enables a complex and infinitely variable plasticity in construction generated with incredible speed and precision. Prototyping processes such as 3D printing are also now being tested with multiple materials for full-scale objects, enabling a compression in the design process as we move directly from design to fabrication. Experiments in multiple media, such as a studio we're running this spring, focused on digital mold making, prototyping, and ceramic casting, expands this terrain. And CCA, because it is a school that originally was CCAC, where the last C, which stood for crafts, was dropped. We have wood, metal, glass, and ceramics that is part of sort of the long history of CCA that I'm now embarking on trying to link up with architecture in more contemporary ways. Advanced visualization focuses on expanding visual techniques in the radical representation of form and space, as well as in the mapping and diagramming of information. The linking of data to form enables us to not only increase our capacity to transpose and spatialize information, thus extending our research capacity through the production of digital diagrams and datascapes, but also ensures that the 2- and 3-dimensional visualization techniques that we're using for both design and communication have now an embodied intelligence, which I think is one of the largest changes that have happened with data-based visualization programs. Our ability to visualize complex iterations and multiple trajectories within a design process, or construct building information models that are linked to databases, are transforming our strategies for research, design, and communication. They also enable us to hypothesize in design and play out the multiple potential iterations by thinking through it in a very different way. And the last area that we're working in is in smart materials, robotics, and interactive technologies that have also enabled the evolution of responsive environments that operate in real time. Variable interactive skins, for example, that change in response to climate, light, and movement are indicative of a larger trajectory of a future responsive interactive architectures that are, I would say, in direct opposition to the controlled universal environments of modernism, where strategies now for environmental response, filtration, and interaction are replacing the idea of environmental control. These areas of research that I've described that are part of our curriculum or embedded within our curriculum and coursework are also specifically linked with a range of CCA faculty expertise and professional research. Examples include the interior landscapes and program surfaces of Tom Falders's BAMscape project for the Berkeley Art Museum, the OpSpace exhibition that was developed for 01 San Jose Biennale by Mona El-Kafif and Corey Beek, Tom Falders's Airspace Tokyo facade project that suspends a screen of articulated voids constituting an open-celled meshwork that varies in density in response to the building's internal program, while also refracting sunlight, channeling rainwater, and buffering wind. In many of these projects, such as the Jellyfish House, this is by Iwamoto Scott, Craig Scott is a member of our faculty, complexity is generated through the synthetic growth of an envelope or system which acts as a receptor, mediator, and index of internal and external forces. Often internal programmatic directives that lead toward generative development and the diversification of architectural form, and external environmental forces and constraints with which this form interacts and to which it continuously adapts. processes that themselves are quite specific to digital technologies. Parametric design, scripting, and fabrication strategies are developed through many of these projects, such as the Voussoir Cloud project, also by Yamamoto Scott, that explores the structural paradigm of pure compression coupled with an ultralight weight material system. Here, a series of tessellated vaults are created based on packing a modulated cell system of folded petals that are made of very thin wood laminate. Andrew Cudless, a graduate of the AA and a previous student of mine at Tulane University, who's also on our faculty, parametrically generated and digitally fabricated the Seawall project, and more recently his P-Wall installation at the SF MoMA, that's now a permanent installation at the SF MoMA, employs scripting to generate a structural patterning of dowels across a hexagonal cellular system, linking computation with material explorations in the production of cast plaster panels that define a new interior skin for the museum. Material experimentation with CNC milling and casting strategies have also been developed for work in concrete and silicone by Corey Beek and Andre Karadek, in folded plastics for the interference screen and the wood pneumatic footing piece that was developed by my own studio and the Bodywork series of installations. The surfacing stone project that was developed at the GSD, that was run by Jessica Lizagore, one of our faculty currently teaching digital fabrication, and innovation and experimentation in digital mold making and ceramics casting by Joshua Stein of Radical Craft in his Tectonic Horizon series. In this project, an interlocking system of slip cast ceramic parametrically developed modules takes advantage of the texture created by the machining process and creates a family of casts that are differentiated through post-processing modifications. Robotics and responsive and interactive environments are the subjects of exploration in a number of projects by Future Cities Lab, run by CCA faculty Jason Johnson and Natalie Gattegno. These include the Zero Max interactive prototype for a responsive second skin developed for the biodiversity exhibition, and the Aurora project that was installed at the Van Allen Institute that is an interactive spatial mapping of the shifting territorial resources in the Arctic that translates the shifting dimensions of the Arctic ice field into an immersive system of flickering auroras and responsive luminescent skins. It's an interactive piece that we could say is a form of 3D mapping. Interactive environments was also the field of exploration of the Reef installation at the Storefront for Art and Architecture in New York that was developed by Joshua Stein and Rob Levy, a project that tries to redefine the role of the architectural envelope by capitalizing on emerging material technologies such as shape memory alloys that might imbue space with behavioral qualities. These and other projects explore the potential of interactive embedded technologies that expand both the use value of designed objects as well as their atmospheric qualitative effects. The microscale of miniaturized technologies enable them to be embedded, producing a new surface material intelligent, a sensate sensibility, with performative properties having applications that range from furniture, textiles, and interiors to enviro-responsive building skins. These and the many projects and many other projects represent the range of research trajectories we're collectively embarking on at CCA. The paradigm shift in technology can be seen to also indicate a necessary shift in the ways in which we're approaching education that might operate through more expanded networks for research, implementation, and dissemination, and that would involve a shifting the spatial and temporal increments of typical programs and coursework to allow for overlaps between education, the profession, and industry, and that might start to generate new models for working. The concept that multiple constituents can be served by a single source is in some ways antithetical to the trajectories that are now evident in both practice and education, which are becoming more multivalent, complex, innovative, integrated, networked, and also decentralized. We should perhaps be looking to other models, software models, such as plugins, which was the idea of, sort of characterizes our workshops. They become like little pieces of software that are injected into the curriculum, or post-industrial models such as mass customization, and to think of this through the structure of education, to reconceive the ways in which we're delivering education that would not only involve a more diverse group of participants, from typical students to also mid-career professionals, but also to produce a more complex set of outcomes that extend the trajectory of professional education to include advanced research, and involves a more complex and closely aligned relationship with both the profession and industry, or the industries with which we hope to engage, if our intention is in some ways to direct the growth and development of the use of these technologies in relation to design in a more synthetic and intelligent way. Thank you very much.
Thank you, Ila. Next, I'd like you to welcome Jonathan Solomon and Tom Verbes from the University of Hong Kong. Jonathan is acting head of the Department of Architecture at the university. He's an American-based architect, an American architect based in Hong Kong, I should say, where he's assistant professor and acting head of the department. He holds a Bachelor of Arts from Columbia University and a Master of Architecture and Certificate in Media and Modernity from Princeton University. He's a licensed architect and member of the American Institute of Architects. Jonathan is a founding editor of 30, 60, 90 Books, a journal of architecture, landscape, and urbanism that publishes its 14th volume, Making a Case, in 2011. And I think, actually, I have volume number 3.